Let's say limit as x approaches 0 from x squared cosine pi over x. So this is a limit, and I know that this part approaches 0, but this one is dne, and 0 times dne is not 0. Could be. So then I start with cosine pi over x, and I say, okay.
No, it lives between negative
Yeah,
1.
exactly, negative 1 and 1 for sure. And then I will multiply all three sides by x squared, because x squared is positive and it's not 0. When x approaches 0, we mean x is not 0. So then I have negative x squared less than x squared cosine pi x less than or equal to x squared. So this is the first part of the squeezing theorem. I showed that this function is squeezed between two other functions. The second hypothesis requires us to find the limit of negative x squared of this function when x approaches 0, and it turns out to be 0. And the limit as x approaches 0 from this other side. And then from 1 and 2, I conclude that limit x approaches 0 from x squared cosine pi over x is 0 by the squeezing theorem. But I have to show both conditions, both hypotheses. I have to make sure that I present two functions that squeeze the original function, and that both functions have the same limit, and it exists, and they have the same limit.
John, we asked, do you know where did you go in student uniform?
Just go down, like scroll down a little bit.
You can do that at the end of the class.
Yeah,
so
but
let's
just you know, right where it says email, under that it should say like student uniform.
Good. Next question. Next topic. Anything else you worked on? Yes.
Can you do
I just went through tests 1, 2, 3, and 4 today, and I don't want to monopolize the whole class though.
But any questions?
I would like to work maybe a little bit more on the L'Hopital's rule, even though
Okay.
extensive
Yes.
problems.
Real quick, I wanted to so I can see the top of it.
So let's look at L'Hopital's rule, and that is in chapter 4.
Can we?
Yes.
Can we go back to that though? Can we? I had more questions on test 1.
Yeah. Yes. You want to work on L'Hopital's rule now, or?
What do you guys want to do?
Okay. Let me.
I have difficulties.
I don't know.
Perfect. Thank you. Okay. Should I choose a L'Hopital's rule now?
I'd rather go in order from.
Okay.
That was question 1
Okay.
on test 1, and
Good.
and I looked at it on the solutions, but this clarifies it.
Good.
Right here. So,
Very good. Next question
let's see
then.
number 5 also.
Okay. What is it?
Because let's. Oh, good. I don't know what the heck I did here.
Did you find the question yet?
5. I did very poorly on.
Okay. So what is what is the problem? Limit.
And I would also like to go over, and I think it's on this test.
So give me a problem so we can start working on it, Eric, so we don't waste the time.
Okay.
So what is it? You said limit?
Yeah, A is limit x approaches 0 from the right, r tan 1 over x.
Good. So you have to remember two functions here that are very important. One function is 1 over x, and we have to remember its graph. Mandatory. This is super important. This is the graph of 1 over x. Doesn't touch here. So 1 over x. And we also have to remember the graph of arctangent. So this is y equals pi over 2 and y equals negative pi over 2. So arctangent looks like this. Without these two functions, so this is arctangent. We graphed them many times. So the first thing I have to do is look at the inner function. When x approaches 0 from the right, the inner function approaches infinity. Then I apply arctangent to infinity. So when x approaches infinity, arctangent approaches pi over 2. So the answer is pi over 2. But this analysis
Okay,
cannot
so
be determined, cannot be...
arctan goes to,
so-
I'm sorry. It says, I just, as 1 over x, okay, goes to infinity, goes to positive infinity, right? Yeah, positive infinity. So what does,
Wait, so you plug in 0? I don't understand, like.
So 0 from the right of this function is positive infinity. Do I understand that part?
Yeah.
So now when this approaches infinity, arctangent of infinity is pi over 2.
Oh, that's what.
Wait, why are you saying it's over infinity?
Arctangent of
But
infinity.
where are you getting infinity?
from 1 over
When x
as-
approaches 0 from the right, 1 over x approaches infinity.
Is that just because 1 over 0 is infinity?
When x
Because-
approaches 0 from the right, the function approaches
it's
infinity.
Like, it's like if the denominator,
So then when
is-
this function
is-
approaches infinity, arctangent of infinity is pi over 2.
So if
I
it's,
think he's trying to say,
I just don't know how you know that it's approaching infinity.
because.
You know,
Which one? You mean this one?
X approaches 0 plus from the.
Do you look at the
See how,
can you look at the graph?
So I pretty much just have to have that memorized.
Absolutely.
Like,
We graph these two functions a million times.
if I can't
do you
memorize
see how
all
it's
this
going
stuff.
to infinity? up
We have
on
to
the-
remember this.
on the-
This
on
is
the
part
right,
this
it's
is part
going
of pre-calculus.
I've already forgotten all this stuff. from
Right,
chapter 1.
but this is part of
chapter 2, I mean.
this is
I
part
have to.
this is part of pre-calculus. This is the basics,
We
the
never did
basic
limits of
information coming into calculus.
pre-calc. Were you supposed to do limits of pre-calc?
No, but the
Okay.
graphs are presented in pre-calc.
Alright.
Yes, and I should be able from little math, right? I should be able to say, okay, yes, this function has a horizontal asymptote y equals 0, has a vertical asymptote x equals 0. When x approaches 0 from the right, the function approaches infinity. When x approaches 0 from the left, the function approaches negative infinity. A minimum understanding of a graph when I look at it, it's part of this class.
It's just gonna be easier for me if I graph it and then look at it.
Yep.
I'm not gonna be able to memorize all 10 billion graphs. I'm gonna have to graph it and look at it.
That's fine. That is fine.
I just-
I'm telling you, I don't know how math teachers or math majors do it, man. I don't know how you guys can memorize some of this stuff.
I'm sure that your skills I could never acquire. We are all balanced.
Everybody,
Has
I consider myself a jack of all trades, but master of none.
well, I don't think that we have to be perfect in something. I don't think. There are people who are perfect in different things. But they're not perfect in everything. Yes, Ali?
Question number B, 10B. The limit is x approaches infinity. What 1 minus e to the x
Which number is it? Which?
divided by 1 plus 2 e to the x, 10B.
Okay.
That's one.
But this one, can we use the hospital's rule if they ask us, or do we just use?
On the final exam, you can use anything you studied unless it's specifically stated. You cannot use anything else but this. So if the problem says find the limit and does not specify anything, you can use any method you like.
But if it's like number 2, it says find the derivative of the function using the definition of the derivative. I can't just use like the
You cannot.
rule
And
or
a problem
the
like that will
division rule,
a problem like that with the difference quotient will be on the final.
versus I have to use the definition.
Yes,
The
but you
fx
can
function
check on the
thing.
scratch paper. You can check with the derivative.
Okay.
But you must present the difference of the limit of the difference quotient.
Yeah, let's see, I had another question.
Hold on 1 second. We haven't finished this one. Is this it? Is this it?
Yeah, that's
Okay, very good. So as we did many times before, if you remember, we factored out,
Now, can you use the hospital rule?
okay? So first I have to check what this is, and the top is infinity, the bottom is infinity, so I can use L'Hopital's rule. So this is limit as x approaches infinity. The derivative of the top is negative e to the x. The derivative of the bottom is 2e to the x. I will simplify and get 1. I will simplify and I get 1, and the answer is negative 1/2.
Now, now, if you do the other one, you factor out e to the x.
Okay, so I factor e to the x, and I get 1 over e to the x minus 1, and e to the x 1 plus 2. No, 1 over e to the x plus 2. These two approach 0. I simplify this, and the answer is negative 1/2.
How do you simplify e to the x?
E to the x divided by e to the x
okay,
is
I
1. E to the x divided by e to the x is 1.
But this isn't that isn't a particular method. That's just it would just say find the limit. So
Yes, it's by factoring.
Okay.
I like Hopkins rule way better.
Yes, I agree.
So much easier.
Yes.
Can we do,
Yes? I think Eric was next.
Oh, I'm sorry. Yeah, you were.
sorry,
Okay, John, till Eric finds it.
How did you say number 1 on the first test?
What does it say?
The limit as x approaches 0 from the right. The square root of x.
Yeah, we just did that.
Oh, you did?
Yeah, with a different function.
Was that the,
Yeah.
but that one is just 0. This one says 0 from the right. So
Okay, let's do that then.
I'm just confused.
Okay, 0 from the right.
Square root of
Because
x-
it's 0 from the right because the square root of x does not exist on 0 from the left.
okay.
That's the only reason. Yeah,
And then it's cosine pi over x.
okay, so negative 1 less than or equal to cosine pi over x less
Okay,
than or
so
equal to
that
1.
this
Multiply
part is
all 3 sides by the square root of x. This approaches 0 when x approaches 0 from the right. This approaches 0 when x approaches 0 from the right. Therefore, by the squeezing theorem, both conditions are fulfilled. The function is squeezed between two functions, and both limits exist, and they are the same number. Therefore, the limit of the square root of x times
So
cosine
what
pi.
is that thing that you did, the negative 1 on the left and the 1 on the right? Where is that coming from?
We know that cosine is a bounded function. Cosine for any angle on the planet cannot be more than 1, and it
It
cannot be
lives in
less
there.
than negative 1.
it lives in that quadrant, maybe, not quadrant,
Range between negative 1 and 1.
there's no.
Sine and
goes up
cosine,
down, it goes to negative, up, positive 1, to negative 1, positive 1, to negative 1.
And then once it gets, and then you just substitute 0 in for x.
no, I multiplied all 3 sides by the square root. Yes. If you,
Right, the last-
after I do that, yes. Then I find that the limit of this function is 0 when x is,
So that equals 0 altogether, right?
yes,
0.
yes,
And then, so just all together equals 0.
yes.
Okay,
I have to write by the squeezing theorem.
fine, okay.
Yes. Eric, did you find it? No. Okay, Ali, go ahead.
So can you do number 3?
What does it mean?
Sketch the graph. Okay, fx equals q. There's 3 different functions. There's the square root of 1 minus x. If x is less than negative 1, then it's x squared minus 1. If between negative 1 and 2, then it's the absolute value of x plus 2 if x is greater than or equal to 2.
Yes, this is a piecewise defined function. We graphed one last time. You want to graph this one too?
Yes.
Okay, so first I have to, is this the equal symbol is here and there is an equal symbol here?
No, there's no equal symbol
For negative 1.
for negative 1.
Okay then. So then I will say this function is defined everywhere except at negative 1. So the domain of this function is negative infinity to negative 1.
Why did you do that?
Yeah.
The function is undefined at negative 1
Why is it not?
Yeah, how do you know?
because there is no equal symbol at negative 1.
Because it's less than -1. And then x is greater than -1. So nothing equals it.
Exactly. So also 2 to the left, a parenthesis and a bracket to the right. So between negative infinity and negative 1, I have to use the square root of 1 minus x. Between negative 1 and 2, I have to use x squared minus 1. And between 2 and infinity, I use the absolute value of x plus 2. Did I copy everything correctly? Is this correct? Okay. So then I plug in, let me see what I want to plug in. So when I plug in negative 1, this will be the square root of 2, right? Yeah. And when I plug in negative 2, I don't want negative 2, I want negative 3. Negative 3, it's 4, so it's 2.
So this part, you just plug in anything between negative infinity to negative 1.
I plug in something that is useful because, for example, negative 2 wasn't useful. I don't want to take the square root of 3. But here I had no choice with negative 1. So negative 1 on this side will be 0. 0 will be negative 1, and 2 will be 3. And on this side, 2 plus 2 will be 4, and for 3 will be 5, and so on and so forth. So now when I graph the function, was this from the test?
Yeah.
Okay. So at negative 3, I have positive 2. At negative 1, I have 1.41. Now this is 0. And at negative 1, oh, I'm sorry. It's here. Negative 1, 0, 0, negative 1, and 2, 1, 2.
So there's two different coordinates, negative 1, 0, and then negative 1 is 2.
So 2, comma 3. So x squared minus 1 is this, and at 1 is 0. So this is quadratic, has a minimum. So this is 2 comma 3. And now 2 comma 4 and 3 comma 5. Yes, please ask your question. What did you want to ask? Sorry.
What did you just do for the two part? 2 on the left is 3.
Two on the left is 3. 2 on the left is 3 right here. 1, 2, 3. 2, 3.
2 on the right is 4.
2 on the right is 4. 2 comma 4. This point. Are there any questions on this problem, or this was just the graph?
Yeah, I was just asking myself.
The graph. Okay, very good.
One of the questions I wanted to really go over,
Yes.
and I don't think I'm ever going to be able to understand it, if you use, I guess, epsilon, it has to do with the precise definition of the limit.
Okay.
Because if you write it with epsilon and stuff, I just can't my brain isn't powerful enough to process these. Trying to learn a new shorthand alphabet.
It's
And
math.
I
It's
just
okay.
I just in the past said I'm just gonna lose 10 points and just try harder to do well on the rest of the points.
I've done that.
Is that what it?
It's like if I know for a fact I can't get something, I focus on everything else that I
Yeah.
won't be able to get.
Okay.
So
So
I
what
don't
am I
know,
doing?
maybe if you can write it out without using it as the least. I don't know.
Okay. So what problem is that?
It's I have number 11.
Okay. Limit.
Test 1.
Limit.
The limit as x approaches 1
Yes.
of 1 minus 3x over 2 equals 1.
So-
I don't.
So
equals
1
I don't know.
1 minus 3 is negative 2.
Oh,
Negative 2
hang on.
divided by 2 is negative 1.
Hold on for a second. It was negative 3 minus 1 is 2. 2 over 2 is negative 1. Is that the answer?
1 minus 3 is negative 2. Negative 2 over 2 is negative 1.
Is that the answer?
No, that's the problem. We still have to find delta.
So what is it? Negative 3 times 1 is negative 3. 1 minus 3 is negative 2. Negative 2 over 2 is negative 1.
I know, but is that the answer?
This is the beginning.
I have no.
That's
I have
what I got.
no.
I haven't written anything yet. So you were trying to prove that this is true using the precise definition of the limit. So this is true. This is true means for any epsilon, I have to use epsilon but that's the if I don't use the epsilon, I can't explain. I have to use the epsilon. For any epsilon greater than 0, I will find delta greater than 0 such that
Every epsilon greater than 0.
anytime I pick x close to 1, I have to write this. I mean, I have no choice. This is part of the definition. I cannot change that part. Every time I pick x close to 1, its f of x will be close to epsilon. I have to write this. I have no choice. Minus negative 1 less than epsilon. I have no choice. I mean, this is part of the definition, and this is part of the definition.
That's the answer.
If you don't, I have not even started.
Oh.
If this is true, this must be true. If this is true, this must be true. So now I have to start from here, where f of x is 1 minus 3x over 2 plus 1 less than epsilon. I have no choice. I have to use these symbols. I cannot do anything else. So 1 minus 3x plus 2 over 2 in absolute value is less than epsilon, which means negative 3x. Can you please stop that? Over 2 is less than epsilon. And then I factor out negative 3, so this is x minus 1 over 2 in epsilon, less than epsilon. And then I have to use a property of the absolute value that says this, that I can change the product. If I have the absolute value of a product, is the product of the absolute values. And the same thing with the ratio. The absolute value of a ratio is the ratio of the absolute values. But this is 3 and this is 2. So now I have 3, x minus 1 over 2 less than epsilon. I have to multiply both sides by 2/3. And then I get the absolute value of x minus 1 is less than 2 epsilon over 3, which is nothing else but delta. So I found that delta equals 2 epsilon over 3. So it means that for any epsilon, if you say, let's use or pick epsilon to be 0.1, I will say yes, in that case, delta will be 0.1 times 2 over 3. If you say, okay, let's pick epsilon to be 0.5, then I'll say, okay, for your epsilon 0.5, I will give you back delta, which is 0.5 times 2 over 3.
Is this anything like the Newton's method?
No.
Way? No.
No. This is the formal definition of the limit.
So that's the answer right there, delta equals 2.
Delta equals 2 epsilon over 3, which means that for any epsilon you give me, I will give you a delta back. So if you say, okay, epsilon is 1, I will give you 2/3. If you say, okay, epsilon is 0.1, then I will multiply 0.1 by 2 and divide by 3, and I'll give you delta. And because this operation can continue forever, for every epsilon you give me, I will say delta is, it means that the limit exists.
So you would, can you like move the paper down like up to the top part? So and to the other, the big thing, the paragraph. Do I need to write that paragraph?
Yes, in any form you want, either plain English or symbols, but you have to write it. Because this means this, and this means this. That's why it's a double equivalency. Yes. Without writing all this, you will not be able to come up with a starting point. You have to write it. Yes.
Question.
Yes.
This is algebra. I don't know if you should do the whole thing.
So before we continue to something else, do you still have questions on this problem?
I'm just gonna have to.
So this says for, that's fine.
Really
This says for any epsilon, give me any epsilon.
7.
It's a number greater than 0. But if you use epsilon 7, that's huge. We want to show that for any small, you can make epsilon as small as you want.
2.
I will give you delta back. I'm talking about 0.1, 0.2, 0.3. So to show that no matter how close you want to be, you want to have a function value to the limit as close as you wanted it. Every time I will give you back a delta. But if you say 7, then it's way too big. I will give you a delta. Delta is 14 over 3. If you say 1, it's 2/3.
So delta is like the difference between.
Delta is the asymmetric interval around -1, which is the value of the limit, where the function lies. The function gets closer and closer to -1 as x gets closer and closer to 1. That's the concept, right?
Okay.
So then you will say, okay, let's check if you will be able to find an x close to 1, any x you want, and you'll say, yeah, of course, I will find for any epsilon as close as you want to be to the limit, which is -1, I'll give you a delta. Where to pick x to ensure that f of x is within that distance away from the limit. Why? Because the limit exists. This mechanism will not work if the limit did not exist.
Would it be helpful to make a graph of that or no?
Yeah, if it's we made graphs all the
I
time.
know we
Yeah,
at
yeah.
least a couple times.
Yeah. You can, and you can also look at you can also look at numerical examples in the book if that helps. Yes,
11.
I think Ali was next.
Oh, I'm sorry.
Question 10. The limit as x approaches infinity. Parentheses, the square root of x squared plus 4x plus 1. Yeah, minus x.
Good.
Which number is that?
10.
Okay, very good. So this is an indeterminate case because this approaches infinity and this approaches infinity, but because there is a minus in between, this is one of the 7 indeterminate cases. the only thing I can do here is rationalize. So I will have the square root of x squared plus 4x plus 1. This is not the L'Hopital's rule. Infinity minus infinity is not L'Hopital's rule. So x squared plus 4x plus 1 plus x. So then this is limit. So x approaches infinity from x squared plus 4x plus 1 minus x squared over the square root of x squared plus 4x plus 1 plus x. These two go away. So then limit as x approaches infinity, 4x over. I will have to factor out x squared here. 1 plus 4 over x plus 1 over x squared and plus x. Since x approaches infinity, the square root of x squared can be written as x.
Okay, this is what I don't understand.
Okay.
I don't understand this stuff.
Yeah, I don't even understand why you like put the original equation over the original equation.
I'm rationalizing. In order to rationalize an expression, you have to multiply and divide by the same thing, so it's 1. If this thing is not 1, then I cannot multiply. I'm changing the expression.
I was rationalizing the numerator.
I don't have anything else but the numerator.
What's that? Okay.
I don't have a denominator.
Well, the denominator is 1.
Yeah, so I cannot rationalize something that is all.
Multiply the top and the bottom by.
I cannot rationalize something that is already rational.
But I'm saying that you're rationalizing the top, the numerator, so you're multiplying.
Because I cannot rationalize the denominator, it's already
Yeah,
rational.
that's what I'm saying. So
Yeah.
you're rationalizing the numerator.
Yes.
And multiplying the denominator by the numerator, right?
I'm multiplying the numerator and the denominator by the same quantity.
Okay.
So I'm multiplying the top by 5 and the bottom by 5.
Okay.
I'm allowed to do that because that is 1. And I'm not changing the expression.
Okay.
But if I multiply the top by 5, but I don't multiply the bottom by 5, then I change the whole thing to something I want to work with.
I think we're maybe getting confused with this being L'Hopital's rule.
It's not L'Hopital's rule.
I know, but
L'Hopital's
I'm
rule is
saying-
0 over 0 or infinity over
Yeah.
infinity. This is infinity minus infinity. It has nothing to do with L'Hopital's rule.
Yeah, the whole limits, the whole limit section.
I only thought it was really only use it. It's like a quotient.
Yes?
Back to my question. What happened? The last step you just written?
So is this clear now?
Yeah.
Okay. Then when I multiply top by top, I get this. And if you're asking why, I'm going to say the formula is a plus b times a minus b, which is a squared minus b squared. Then I copy the denominator. Is this step from here clear?
Yes.
Okay, good. Then I simplify. Is this step from here clear?
Kind of. I don't know why though. I don't know why you don't factor it. But yeah.
I can factor anything I want from anything I want.
Okay.
So for example, that is very important. So if you want from x squared plus 4x plus 1, I can factor 7. From the same quantity, I can factor out x squared. From the same quantity, I can factor 100. From the same quantity, I can factor out x plus y. I can factor this. From any quantity, I can factor out anything I want, anything I decide to factor, assuming it serves a purpose. I'm not going to factor out this because it's not going to serve any purpose. So coming back to my problem, I would factor out x squared because it serves me a purpose. And you will see the purpose in a second. So the square root of x squared is x. If x approaches negative infinity, it would have been negative x, because that's how the absolute value works. But in this case, the square root of x squared is x because x approaches infinity. And now I see two terms and they have x in common. I will factor out x. So I continue. So then the limit x approaches infinity from 4x divided by x in parentheses, the square root of 1 plus 4 over x plus 1 over x squared and plus 1. I will, of course, like we did always, we simplify the 1. And now when I plug in infinity, I shouldn't say that because I'm only saying when x approaches infinity, I know this approaches 0, this approaches 0. The square root approaches 1. 1 plus 1 is 2, and 4 divided by 2 is 2. So therefore, I would say that this function, the square root minus x, has a horizontal asymptote at infinity. And the horizontal asymptote is y equals 2.
Anything over infinity is 0, okay?
Anything over infinity is 0.
Okay. And what
If
did
it's a constant.
Yeah, okay. And what did you say about the asymptote?
So when x approaches infinity, if a function approaches a number, that is the horizontal asymptote.
2 is the horizontal asymptote.
Y equals 2 horizontal asymptote at infinity only. Eric, go ahead. Next question.
Should we
I was
do?
gonna,
Don't forget to show up for the final exam Tuesday.
me?
No, you in general for the final, because I don't want to calculate a grade with a 0 instead of something else for the final.
What
So
time?
don't forget.
What time? Same time, right?
5 to 8 on Tuesday.
Okay, 5 to 8.
Do not call me 5 minutes before to say that something came up, because I can't.
It's gonna be a 3-hour exam?
I'll be here from 5. They can start at 5.
On Tuesday. Okay. That is the 7th. What's the date?
The 9, the 8th.
So we do number 8.
Yes.
It's, find the equation of the tangent line to the curve y equals the square root of x minus 2 at 11, 3.
Good. So y prime equals 1 over 2 the square root of x minus 2. And then y prime evaluated for x equals 11 is 1 over 11 minus 2 is 9. The square root of 9 is 3. 3 times 2 is 6. So then y minus y1 equals the slope times x minus x1, where the slope is 1/6 and the point is 11 and 3. So y minus 3 equals 1/6 x minus 11. So x over 6 minus 11 over 6 and plus 3. So this needs a 6. 18 minus 11 is 7. This is the equation of the line tangent to the graph of y equals the square root of x minus 2 at 11, 3.
This is number 8. Alright, now can you go back and like go over what you just did, please?
Yeah, I found the derivative and I plugged in 11.
Okay, so you plug in 11, 1 over 6.
Yeah, and then I used y equals mx plus 8.
Oh,
Y
so
minus 1 equals
Y minus y1 equals the slope times x minus 1.
slope.
I don't have to use
And
that.
the slope is 1 over 6.
Yes, because the derivative gives the slope of the tangent line at any point. That's the definition of the derivative. It gives the slope of the tangent line to the graph of the function at
So-
any point.
So you didn't need to use the 3 at the beginning, like you only plugged in 11?
Yes,
Minus 2.
because when I evaluate the derivative, I cannot evaluate the derivative for y. I evaluate the derivative for x, when x is.
11 minus 2 is 9. So it's 3. So it is
And then after you did the y minus y sub and all that, everything else you just did from there is just algebra.
Right. I distributed 1/6 and I moved 3 to the other side and I found the least common denominator and
Now, why don't you, well, I guess it's the same thing. I mean, it's the same thing, as I could write x plus 7 over 6, it's the same thing, right?
Could you move up?
X,
X plus 7 over 6?
yes, you can, yes.
Does it matter, will I get either way?
No, it's the same thing. We normally write it in the mx plus b format, but it doesn't matter really.
You don't have to use that long one.
Yes, if it's asking you to find the derivative using the definition of the derivative, then you have to.
But this isn't, it's just saying find the equation of the tangent line. The tangent
It doesn't
is,
say, then you can use now because it's a final exam. You can use any method you like.
and finding the equation of the tangent line is the derivative, like the tangent is the derivative, right?
No, the slope of the tangent is the derivative.
Okay.
Only, yes.
So where did you get, okay, so I see you got y prime is 1 over 2x minus 2, but you don't do the chain rule and multiply it by, that's multipliable 1. And what you do, you put 11 into that. 3 comes through 6, 1/6 through the slope. Okay, I see. I got it, I'm sorry.
Good.
So we did the next one, number 9.
Okay, what does it say?
Find horizontal and vertical asymptotes of the function,
Yes,
including the pertaining limits.
good.
F of x equals x minus 1 over x squared minus 3x plus 2.
Good. So this is x minus 1 over x minus 1, x minus 2. The function is undefined at 1. The function is undefined at 2. However, x minus 1 will disappear. So x equals 1 is the hole in the graph, not a vertical asymptote. So the only vertical asymptote is x equals 2, is a VA. So I have to show limit. As x approaches 2 from the left of 1 over x minus 2, and limit as x approaches 2 from the right of 1 over x minus 2. So it's 1 over 2 from the left, which is 1.9. 1.9 minus 2 would be negative infinity, and 2 from the right is 2.1. 2.1 minus 2 is positive, so it's infinity. And now the function, the simplified form is 1 over x minus 2. Limit as x approaches infinity or x, so I don't write it twice, of 1 over x minus 2 is 0. Y equals 0 is a horizontal asymptote.